Okay. Okay. Can you see the screen?
Yes,
Yes,
sir.
sir.
Okay. So in the previous lecture, we stopped here. Okay. The u dash of x, mod of u dash of x is less than or equal to 2 in k into mod of phi of x bracket square plus mod of phi dash of x bracket square. Okay. Up to here, any doubt? Any doubts,
No,
sir?
sir.
Okay. So this is the mod of u dash of x. Okay, this is the mod of u dash of x. Now, this implies that u dash of x, mod of u dash of x is less than or equal to 2 into k into norm of pi of x, bracket square. What is the value of this one is norm of pi of x bracket square. Okay, इकडे. Okay, where this one is norm of phi of nothing but what? This one. Okay, if mod x is less than a, then it implies that x running from minus a to a. Okay, हे माहिती आहे result. If mod x is less than a, then x minus 1 हा तुमचा plus 1 for example. Okay, here suppose mod x is less than 1. So what are the possibilities of x? X
-1
running
and
from
+1.
-1 to 1. Okay, जर ते लेस इक्वल असेल तर तिथे काय एक लेस इक्वल येणार. ओके, या -1 to 1 तुम्ही व्हॅल्यू घेऊ शकता. Okay, we have one result, this one. If mod x is less than or less than a, then we have x is running between -a to a. Okay, this implies minus 2k into norm of phi of x bracket square is less than or equal to u dash of x is less than or equal to 2 into k into norm of phi of x bracket square. Okay, give it as question number 5. Okay, now consider the right half inequality. Right half of of above inequality. Okay, then what we get? U dash of x is less than or equal to 2 into k into pi of x bracket square. Okay, but which implies that u dash of x is less than or equal to 2 into k. But what is the value of this one? Is nothing but u of x. Okay, from here considered as u of x is nothing but what? Norm of phi of x bracket square whole square, norm square of phi x. So putting this value here, we get u dash of x is less than or equal to 2 into k into u of x. Okay, any doubt up to here?
No, sir.
Which implies that u dash of x upon u of x is less than or equal to 2 into k. Okay, now the case number 1. What is the case 1? Case number 1. If suppose x is greater than x naught, then integration integration above inequality above inequality with respect to x. Integrate the above equation with respect to x from x naught to x. Why? Lower limit is x naught and upper limit is x, because x naught is less than x. Then we get integration x naught to x u dash of x upon u of x is less than or equal to 2k is the constant, where x naught to x, here dx. Okay, here also dx is there. Okay, we integrate the equation with respect to x. Okay, so what we get? What is the integration of this one? Tell me,
Log
what
of
is
ux.
log of u of x? Okay, from upper limit, the lower limit x naught to x, which is less than or equal to 2 into k into x, upper limit, lower limit x naught to this x. Okay, which implies that log of u of x minus log of u of x naught is less than or equal to 2 into k into x minus x naught. Okay, which implies that log of u of x upon u of x naught, okay, which is less than or equal to 2 into k into x minus x naught. Any doubt up to here?
No, sir.
We know that if log x is equal to a, then what it implies? E raised to a is equal to x, na? So using that rule here, we get here the base is what? E. So here we get e raised to 2k into x minus x naught, which is less than or equal to, sorry, x minus x naught, okay, which is greater than or equal to what? U of x
ux.
upon u of
Ux
x
not.
naught. Okay, you can write like this also. You can write like this: u of x upon u of x naught is less than or equal to e raised to 2k into x minus x naught. Okay, which implies that u of x is less than or equal to, okay, u of x naught into e raised to 2 into bracket into k, where x minus x naught. Okay, now replace this u of x by phi of x. Now replace this u of x by norm of phi of x bracket square. So what we get here, which implies that norm of phi of x bracket square is less than or equal to norm of phi of x naught bracket square into e raised to 2k into x minus x naught. Okay, any doubt up to here?
No, sir.
Now taking square roots on both sides, what we get? Phi of x, which is less than or equal to phi of x naught into e raised to k into x minus x naught. Give it as an equation number 6. Up to here. Any doubt?
No, sir.
Okay. Now again, consider similarly. Similarly, by considering left half, okay, left half of inequality 5, we get inequality of 5. We get what we get? Phi of x naught into e raised to minus k into x minus x naught which is less than or equal to phi of x. Okay, give it as equation number 7. Look at here. What is the equation number 5? Here. Now considering this half inequality, okay, left inequality. Again by similar process. By doing similar process, what we get? This one. Sorry, here the norm of phi of x not norm of phi of x naught into e raised to minus k x minus x naught, which is less than or equal to norm of phi of x to here. Now combining the equation 6 and 7, we get we get norm of phi of x naught into e raised to minus k to x minus x naught. Okay, this is not mod by, this is the bracket in bracket x minus x naught. Okay, this is the not mod, which is less than or equal to norm of phi of x, which is less than or equal to norm of phi of x naught into e raised to k into x minus x naught. Okay, any doubt?
No, sir.
Now the case number second, case 2. Now case 2 is there. Now assume, suppose if x naught is greater than x, okay, then we have x naught minus x is greater than 0. Case number 1 ला काय होता, x is greater than x naught. Now here the case 2 is if x naught is greater than x, then what we get? X naught minus x is greater than 0. Similarly, okay, similarly from inequality 5, 8, sorry, from inequality, give it as equation number 8. Okay, inequality 8, we get what we get? Look at here. Norm of phi of x naught is equal to e raised to minus k. Now here not x minus x naught. Here x naught minus x we have. Okay, which is less than or equal to phi of x, norm of phi of x, which is less than or equal to norm of phi of x naught into e raised to k into x naught minus x. Okay, इथे x हा कुठा होता? Okay, give it as an equation number 9. Okay, now combining 8 and 9. Here x is greater and here x naught is greater. Now combining these two equations, we get mod. Okay, the difference between these two, x and x naught. So now combining from 8 and 9, from 8 and 9, what we get? Norm of phi of x naught into e raised to minus k. Now here the bracket goes and comes here mod x minus x naught. Okay, which is less than or equal to norm of phi of x, which is less than or equal to norm of phi of x naught against the proof of this theorem. Okay, x naught minus x साठी पण हे ट्रू आहे आणि x minus x साठी पण हे ट्रू आहे. So combining these two equation, we get here mod x minus x naught. Okay, so this is the proof of the theorem. So what we have proved? Look at this theorem. If phi is the solution of L of y, y double dash plus ay dash plus a2y is equal to 0 on an interval I containing the point x naught, then for all x belongs to I, we have norm of phi of x naught into e raised to minus k mod x minus x naught less than or equal to norm phi of x, which is less than or equal to e raised to k into mod x minus x naught into norm of phi of x naught. Okay, where k is the 1 plus mod a1 plus mod a2. Okay, and phi norm of phi of x is equal to mod of phi of x bracket square plus mod of phi dash of bracket square whole bracket raised to 1 by 2. Okay, फक्त calculative part आहे याच्यात. Okay, any doubt in this theorem?
No, sir.
एकदा दोनदा लिहून काढा, तीन चारदा प्रॅक्टिस करा हे, मग ऑटोमॅटिक तुम्हाला एकदा समजून जाईल. ओके, कोणकोणते हे काय म्हणतात त्याला प्रॉपर्टीज याच्यात यूज केलेले आहेत, काय यूज केलेले आहेत. ओके, वाय दिस वी आर गोइंग टू ऍडिंग दिस टर्म. ओके, हे टर्म काय ऍड केलं तुम्हाला कळण्यासाठी, कारण की के ची व्हॅल्यू आपल्याला काय सेट करायचे, 1 प्लस मॉड ए1 प्लस मॉड ए2. ओके, हे आपण ऍड केलं म्हणून असं आलं ना इकडे 1 प्लस मॉड ए1 प्लस ए2. दिस इज नथिंग बट के. ओके, एनी डाउट इन दिस theorem? Can we move towards the next point?
Yes, sir.
Okay. Now, the next point is linear dependence and independence. Okay. Linear dependence, and independence. Okay. Linear dependence and independence. Okay. Now, definition. What is the definition? Two functions phi1 and phi2 are said to be linearly independent if C1 phi1 plus C2 phi2 is equal to 0. It implies that C1 is equal to 0 and C2 is equal to 0. Okay, so this is the definition of linearly independent functions phi1 and phi2. Okay, if two functions phi1 and phi2 are said to be linearly independent, this may be phi1 and phi2. These are the functions of L of y, maybe or may not be. Okay, हे तुमचे phi1 and phi2 L of y चे functions असूही शकतात किंवा नसूही शकतात. हे काही दिलेलंच नाही आपल्याला. Okay, any arbitrary two functions phi1 and phi2 are said to be linearly independent if C1 phi1 plus C2 phi2 is equal to 0. It implies that C1 is equal to 0 and C2 is equal to 0. Okay, now the two functions phi1 and phi2 are said to be linearly dependent if C1 phi1 plus C2 phi2 is equal to 0. It implies either C1 is not equal to 0 or C2 is not equal to 0. Wait a minute. Either C1 is equal to 0 or C2 is not equal to 0. If one of them is not equal to 0, then it is the linearly independent. That means that one is the scalar multiple of other. Then the functions are linearly dependent. Okay, if C1 and C2 both are non-zero, sorry, 0, then the functions are linearly independent. Okay, wait for a minute, we can take an example. for example number 1, look at here. Let phi 1 of x is equal to x and phi 2 of x is equal to e raised to rx. Okay, then what we have, c1 phi 1 plus c2 phi 2 is equal to 0. Okay, which implies that c1x plus c2 e raised to rx is equal to 0. Now differentiate this with respect to x. Now why we are going to differentiate कळेल तुम्हाला. Okay, again now differentiate with respect to x, which implies that c1 plus c2x e raised to rx is equal to 0. Now this is the equation number 1 and this is the equation number 2. Now the equation number 1 and equation
C2R
number,
into e raised to Rx, sir, na?
oh sorry, this is r, sorry, this is the r into e raised to rx. Okay, r is the constant here. Okay, now these are the two equations which are in the linear form, and this is the system of linear equations. Okay, ह्या काय सिस्टीम ऑफ लिनियर इक्वेशन्स आहेत. मग ह्या सिस्टीम ऑफ लिनियर इक्वेशन्सला युनिक सोल्युशन कधी असेल, जेव्हा त्यांच्या डेल्टा, त्यांचा डिटर्मिनंट काय असतो, नॉट इक्वल टू 0. सो डेल्टा इज, व्हॉट इज डेल्टा हियर, व्हॉट वी हॅव, phi 1 phi 2 phi 1 dash and phi 2 dash. ओके, काय इथं कळतंय का असं पहा पुन्हा.
Yes, sir.
या सिस्टीम ऑफ लिनियर इक्वेशन, टू इक्वेशन आपण मॅट्रिक्स फॉर्म मध्ये कसं लिहिणार, असं लिहिणार ना. काय लिहिणार इथे, एक्स e raised to rx, here 1 and here r into e raised to rx, which implies here c1 and c2 which is equal to 0 and 0. This is the column vector, and if this matrix is invertible, then we have c1 and c2 are the unique solution. We get the unique solution for this system of linear equation. मग या सिस्टीम ऑफ लिनियर इक्वेशनला युनिक कधी येतील, जेव्हा ह्याचा इन्व्हर्टिबल असेल. हा इन्व्हर्टिबल कधी येईल, जेव्हा हा डिटर्मिनंट नॉट इक्वल टू काय येईल, 0 येईल. ओके, जर नॉन इक्वल टू 0 आला म्हणजे हा काय येतो, इन्व्हर्टिबल. हा इन्व्हर्टिबल आला म्हणजे काय होणार, c1 आणि c2 ची व्हॅल्यू काय येणार, 0 येणार, युनिक सोल्युशन. ओके, that's why we are taking the delta as like this. Okay, म्हणजेच डेल्टा काय येणार तुमचा, पुढले put here delta is equal to, what is the phi, x, what is the phi 2, phi 1 is x, phi 2 is e raised to rx, here phi 1 dash 1, here r into e raised to rx. Okay, which is equal to x into r into e raised to rx minus e raised to rx. Now, taking common, e raised to rx is equal to xr plus, sorry, minus 1. Okay, so xr minus 1, which is not equal to 0. Okay, at least one point ला जरी not equal to 0 आला तर काय होईल तो, that function is not equal to 0. Okay, हा तर तुमचा पॉझिटिव्ह असणार नेहमी. e raised to rx is always positive function. Okay, any doubt?
No, sir.
R is equal to 0, hence which is not equal to 0. It means the system has linear, the system has unique solution. म्हणजे हा तुमचा काय झाला, इन्व्हर्टिबल झाला नॉन इक्वल टू 0 म्हणल्यानंतर. मग c1 आणि c2 मस्ट बी इक्वल टू काय असायला पाहिजे, 0. हा तिकडे गेल्यानंतर काय होणार, ह्याचा इन्व्हर्स येणार इकडे, इन्व्हर्स इंटू 0, कॉलम वेक्टर तुमचा 0 वेक्टर आहे, मग काय येणार, हा 0च येणार ना. ओके, हा इकडे तुमचा मॅट्रिक्स हा इकडे गेलाय, इकडे गेल्यानंतर काय होणार, हा तुमचा इन्व्हर्स येणार, काहीतरी एक इन्व्हर्स मॅट्रिक्स. ओके, हा इन्व्हर्स मॅट्रिक्स आणि तुमचा कॉलम वेक्टर, हा प्रोडक्ट काय येणार तुमचा, 0 0 येणार. ओके, कळतंय का. Hence
Oh,
c1
sir.
and c2 must be equal to 0. C1 equal to C2 is equal to 0. Hence, phi1 of x, which is equal to x, and phi2 of x, which is equal to e raised to rx, are independent functions. ओके नॉट सोल्युशन हे सोल्युशन दिलं आहे का तुम्हाला माहिती नाही ते ओके फाय वन अँड सोल्युशन
No,
आहे
sir.
आहेत का काही डाऊट्स
No, sir.
ओके तसं कळत नसेल तर ही अजून एक मेथड आहे त्याची we have c1 phi1 plus c2 phi2 is equal to 0 what it implies c1x plus c2 e raised to rx is equal to 0 now differentiate with respect to x what we get here c1 okay plus C2 e raised to Rx is equal to 0. So R into e raised to Rx which is equal to 0. But this is always positive, which implies C2 is equal to 0. Now put this C2 here. What we get? C1 is equal to 0. Okay? ओके त्याचे अजून काही एक्झाम्पल घेऊ मग कळेल तुम्हाला थांबा अजून एक एक्झाम्पल आहे त्याकडे वेट अ मिनिट नेक्स्ट लेक्चरला याचे एक्झाम्पल घेऊयात पुढचे ओके अजून आहेत एक्झाम्पल याचे भरपूर नेक्स्ट लेक्चरला घेऊया okay now the next part is one more theorem is there okay okay the next theorem is the two solutions phi 1 and phi 2 wait a minute here solution uniqueness theorem for the initial value problem okay name of the theorem is uniqueness theorem for an initial value problem now look at the statement let alpha and beta be any constant and x naught be any real number okay real number from an interval from from any interval from any interval I x naught is the point in between this interval I then there exists then there exists at most one solution for initial value problem L of y is equal to y double dash plus a1 y dash plus a2y is equal to 0 and y of x naught is equal to alpha and y dash of x naught is equal to beta. So this is the initial value problem. So what this theorem says the uniqueness of the theorem. What says the uniqueness theorem? Let alpha and beta be the any constant and x naught be the any real number from any interval I, then there exists at most one solution. Okay, जास्तीत जास्त या इक्वेशनला किती सोल्युशन असतील एकच सोल्युशन असेल जी की हे कंडिशन सॅटिस्फाय करतोय ओके युनिकनेस म्हणजे ऍट most one it means that only and only one solution exists for this instance. एकच सोल्युशन येतोय. एकच सोल्युशन येतोय म्हणजे काय, तो युनिकच असायला पाहिजे. Okay, such that y of x naught is equal to alpha and y dash of x naught is equal to beta. Okay, हा शेवटचा थेरम घेऊयात आणि थांबूयात आपण. Okay, any doubt in this theorem?
No, sir.
Existence of
आहात
theorem
का?
for initial value. Sir, existence theorem for initial value problem
आहात
and
ना सगळे बाकीचे?
Yes, sir. I'm
रिप्लाय द्या कोणीतरी.
uniqueness.
Okay. Now let's see the proof. What is given to us? Let L of y is equal to 0. That is y double dash plus a1 y dash plus a2y, which is equal to 0, and y of x naught is equal to alpha and y dash of x naught is equal to beta. Give it is equation number 1, which is given to us. Okay, now suppose we have to prove that there exists a unique solution, uniqueness of the solution. Okay, for this we supposed alpha, sorry, phi and psi are the two solutions. Are the two solutions. Suppose phi and psi are the two solutions of initial value problem 1. Okay, that is, if these are the solution of equation 1, then what we have? L of phi is equal to 0, and also L of psi is also is equal to 0, and such that L of, sorry, phi of x naught is equal to alpha and phi dash of x naught is equal to beta. हा सोल्युशन आहे म्हणजे काय करायला पाहिजे, ह्याची सगळे कंडिशन तो सॅटिस्फाय करायला पाहिजे. And psi of x naught is equal to alpha and psi dash of x naught is equal to beta. Okay, any doubt up to here?
no, sir.
Any doubt?
No, sir.
No, sir. No, sir. No, sir.
डाऊट आहे का काही?
No, sir.
डाऊट आहेत का काही?
No, sir.
Okay.
No, sir.
Okay, now define one more function theta is equal to this phi minus psi. Okay, now consider L of this theta is equal to, what we have L of theta is theta double dash plus a1 theta dash plus a2. Okay, a2 theta. But what is the theta? Phi minus psi, which is double dash plus a1 phi minus psi bracket dash plus a2 phi minus psi. Okay, which is equal to phi double dash minus psi double dash plus a1 phi dash minus psi dash plus a2 phi minus psi. Okay, which is equal to phi double dash plus a1 phi dash plus a2 phi, taking this one in the one bracket. Okay, minus psi double dash plus a1 psi dash plus a2 psi, taking in the another bracket. Okay, but this is nothing but what? L of phi, and this is nothing but L of psi. But phi and psi are the two solutions, but it implies that L of phi is nothing but 0, and this L of psi is nothing but but 0. So 0 minus 0, what we get? 0. Which implies that now here the of L of y is equal to 0. Okay, and also theta of x naught is equal to phi minus psi. What is the theta's value? Phi minus psi into x naught, which is equal to theta of x naught, sorry, phi of x naught minus psi of x naught. But what is the value of phi of x naught? Alpha. What is the value of psi of x naught? Alpha, which is equal to 0. Okay, and also phi dash of x naught, sorry, theta of x naught. Theta of x naught is equal to theta dash of x naught, sorry, phi minus psi bracket dash of x naught, which is equal to phi dash of x naught minus psi dash of x naught. But what is the value of phi dash? Beta. What is the value of this one? Is beta again, which is equal to 0. Hence, here what we have, L of theta is equal to 0 and theta of x naught is equal to 0, and also theta of theta dash of x naught is equal to 0. Okay, since hence theta is the
सर आवाज येत नाहीये.
what we have, this one is norm of, instead of here phi we put here theta in the previous theorem, this x naught into e raised to minus k mod x minus x naught, which is less than or equal to norm of, sorry, this is theta of x, okay, which is less than or equal to norm of theta of x naught into e raised to k into mod of x minus x naught. Okay, for all x belongs to what? I. This is true for all x belongs to I. Okay, but here theta of x naught is equal to 0. Okay, this is the value 0, which implies that norm of theta of x naught is also is equal to 0. Okay, any doubt up to here?
No, sir.
No, sir.
So give it as equation number 2. Okay, now the putting this value in equation 2, we get equation 2 becomes 0 norm of theta of x, which is less than or equal to 0 into e raised to k into mod of x minus x naught. Okay, which implies that 0 is less than or equal to norm of theta of x, which is less than or equal to 0. What it implies? Yes, for all x
Norm
belongs
of
to I, na?
theta of x
For all
equal to
x
0.
belongs to I, which implies that norm of theta of x is equal to 0 for all x belongs to I, which implies that this is 0 for all x belongs to I, which implies that the itself theta of x is equal to 0. Okay, but what is the value of theta? Phi of x minus psi of x, which is equal to 0, which implies that theta of x is equal to psi of x. Okay, which implies that phi is nothing but psi on whole interval I. Thus, for every initial value problem, there exists only one unique solution. One solution which is unique. Okay, any doubt up to here?
No, sir.
म्हणजे काय केलंय आपण ह्याच्यात घेताना आधी युनिक सोल्युशन दाखवायचं. याच्यासाठी काय करणार, आपल्याला दोन सोल्युशन आहे असं अज्युम केलंय. ऍट द एंड वी आर प्रूव्हिंग दॅट ते दोन्ही वेगळे नसून एकच आहेत. ओके, एनी डाऊट?
No, sir.
एनी डाऊट अप टू हिअर? ऐकू येते का नाही कोणाला? कोणीच
No,
रिप्लाय
sir.
देत नाही.
Yes, sir.
येते
आहात
सर.
का नाही कोणी?
Yes,
कुलकर्णी आहात का?
येस सर.
येस सर.
आहात का कुलकर्णी?
सरांना आवाज
ओके, तुमचा आवाज ऐकू येत नाही मला.
सर.
माझा आवाज जातोय तुमच्याकडे,
हॅलो
तुमचा आवाज ऐकू येत नाही. ओके
सर.
ओके ओके, तुमचा आवाज ऐकू येत नसल्यामुळे तसं होत असेल, काहीतरी प्रॉब्लेम झाला असेल. ओके, एनी डाऊट? प्लीज राईट इन द चॅट बॉक्स. ओके, so here we proved for any initial value problem, sorry, initial value problem, there okay, so for today it is sufficient. So in the next lecture we will
सर.
discuss what is the row scheme. Okay, what is the meaning of row scheme, and using row scheme we prove how the functions phi1 and phi2 are linearly independent or dependent. Okay, wait for the 2 minutes. I will take an attendance. हा, काय क्वेश्चन आहे विचारा, चॅट बॉक्स मध्ये टाईप करा. तुमचा आवाज माझ्याकडे ऐकू येत नाहीये कदाचित. मला ऐकू येत नाही. वेट फॉर अ मिनिट. ओके, तुमचं जे काही जे क्वेश्चन असेल तर आपण ते नेक्स्ट लेक्चरला, उद्याच्या लेक्चरला बघूयात. ओके, कांचन शेंडगे. ओके, so today it is sufficient. Okay, thank you for the attending the lecture. You can leave now. Hello.